In this topic, we will be discussing about Gauss-Jordan method. As a review, the principle of Gauss-Jordan method requires us to derive a unity matrix wherein all the diagonal elements above and below the diagonal values of 1 should be equal to 0. For the sake of this discussion, we will be using the previous example we had in Gaussian elimination method, wherein we have already zeroed in the lower triangular elements of our equation into 0, and now we only need to convert or to make all the diagonal elements in the upper triangular portion of our diagonal into 0. So the first step, since we have to make it as a unity matrix, is to convert all these elements here above the element 1 in column D equal to 0. In order to make that 0, we need the working formula. R3 is equal to R3 minus the element in row 3, column 4 times row 4. And in order to make this one into 0, we need the formula R2 is equal to R2 minus the element in row 2, column 4 times R4. And in order to make this one into 0, we need the formula R1, or the new R1, is equal to R1 minus the element in row 1, column 4 times R4. So it is very easy to make this formula because, as we have said, if you have noticed the pattern, they are paired R1, E1, 4, 4. R2 is E2, 4, 4, and so on. So we will apply this derived formula to this equation here. So to make this element into 0, so we will use this formula. So I will start it with this one. So as you have noticed, and as what I have discussed in the lesson proper, we will not be touching anymore these answers here in the lower triangular element. Instead, we will be focusing on the upper triangular elements here, because in this portion we have already achieved our goal or our target, that is to zero in the lower triangular elements and to attain the unity value for our diagonal. So again, let's go back here. We will make this element into 0. So we will be applying this formula. So for this element, that is equal to the value of R3 minus the value of the element in row 3, column 4, so that is still this one. And again, as I have said, since this is a constant value that shall be applied in the formula, so I will put a $sign. So again, that will be multiplied to the elements in the row 4, which is equal to 1. Enter. So you have here 0, and all you have to do is drag the formula to get the value of R5. Next, how do we make this 1 into 0? So I will apply the formula that is equal to R2 minus the value of element in row 2, column 4. So that is this one. Again, I will put a $sign since this element will be used as constant in applying in the equation in the entire row times the element in row 4, that is 1. Then the value is 0. And since I need to apply this to all the elements, I could drag to the left, and I could also drag to the right. There you have it. Next is to make this element here into 0. And I will be applying the formula R1 equals R1 minus the element in row 1, column 4, that is itself. So again, $sign multiplied by the element in row 4, which is equal to 1, or the element directly below in row 4. Again, I need to apply it here, so drag to the left, and you can apply it here, drag to the right. There you have it. So let me erase this one first. So we are already in this equation. So our next goal is to make these two elements here in column C, or into 0. We have to make this one into 0. We have to turn that one into 0. And in order to make that into 0, what will be our working equation? Since this element is in row 2, so the value of new row 2 will be equal to R2 minus the element in row 2, column 3, so E23 times R3. Again, take note of the pairing. And for this one, in order to make this one into 0, my formula will be R1 is equal to R1 minus the element in row 1, third column, times R3. So I will apply this formula to the entire equation. So this one, we have R2, so this one, minus the element in the second row, third column, that is still this one. Again, I will put a $sign here, a $sign here, because that will be a fixed value, multiplied by the element in row 3. So that will be 1. And again, I could drag the formula to the right. And in order to make this element into 0, I will be applying this formula. So that is equal to R1, that is R1 minus the element in row 1, column 3, this itself. Again, I will be putting a $sign, multiplied by the element in row 3. Again, in order to apply, I will drag it here, and I could also drag it to the left. So take note that the elements here, I did not touch these elements because these are already derived values in our Gaussian elimination method. So let me have it colored. There. Now, our last step, since these are already 0, these are already 0, the last step is to make the value here above the 1 in the column B into 0. So we have to make this one into 0, or we have to convert that one into 0. And what will be our formula? R1 will be equal to R1 minus the element in row 1, second column, times, that is R2. So applying it, we have here, it is equal to R1 minus the value of the element in the first row, second column. So I'll just put a $sign here, then multiplied by the value of the element in row 2. Then all I have to do is to drag the formula. So as you have seen, I have already derived a unity matrix with the upper triangular elements 0, the lower triangular elements 0, and the diagonal elements 1. So again, the purpose of the Gauss-Jordan method is to eliminate the back substitution, because from here we could directly get the values of our unknown coefficients. So here, from our derived unity equation or unity matrix, we have A is equal to 1, our B is equal to -3, our C is equal to 6, and our D is equal to -4. So this is our, or these are the values of A, B, C, and D. But then, how would you check if your answers are correct? So you may check if your answers are correct by substituting the values to any of our original equation. So let me copy this one first. This is our original equation. So from the equation, we have, so I'll be choosing this equation to check if my answer is correct. So that will be 3a plus b plus 2c plus 4d is equal to -4. So by substituting the value, we have 3 equals 3 times, this is the value of A, 1 plus, what is the value of B? We have -3 plus 2 times C. What is the value of C? 6 plus 4 times, what is the value of D? -4. So -4 should be equal to from the equation, that is minus 4. So see, when you substitute the values here, it is equal to negative 4. So therefore, our answer here is correct. So you may substitute from any of the equation. You may choose the equation 2, you may choose the equation 3, you may choose the equation 4. Just substitute the values derived to check if the constant here corresponds to the values if the variables here are replaced by your answer.